Hello everyone, welcome to Code World, and today we will be going over LeetCode 167, which is two-sum 2. This problem is very similar to two-sum, which is LeetCode number 1, another problem I solved in my channel, but it has a few twists to it. So over here as well, we are given a one-indexed array of integers called numbers. And this array of integers is sorted in non-decreasing order. What this means is basically that it's sorted in increasing order. So not sure why they call it like this, saying it's non-decreasing order. But basically our first element will be the smallest, and as we go on along the array, the value of the numbers will be increasing. So it's in ascending order. And what we want to do is return the indices of the two numbers whose sum is equal to the target that is given to us. And we want to return these indices added by 1. So it's basically considering the array to start with an index of 1 rather than 0. Another thing to keep in mind is that there is only one solution for this problem, and we cannot use the element twice. So basically how this problem differs from two-sum 1 is that the array is sorted in increasing order, and also we're told that our solution must not use any space greater than constant space, right? So we can only use constant space for this solution, meaning we cannot use a map as we did for two-sum 1. So here's an example down below which will make the problem more clear. We have a numbers array and our target is 9. We know that 2 plus 7 is equal to 9, so we want to return the indices of these elements. Now we're told we want to return the indices plus 1, so we're starting with an index of 1. So in this case we'll return 1 and 2 as the indices of 2 and 7. And yeah, so there are two different ways of solving this problem. There's a less efficient way, which has a quadratic time complexity, and a more efficient way, which has a linear time complexity, and I will be showing you both of the algorithms. So let's go on to Excalidraw so I can show you the solutions. Here in Excalidraw, and I have prepared an example for you guys. We have an input of numbers, which is an array containing 2, 7, 8, 11, and 13. And we have an input target, which is 10. So what we want to do is find the two numbers which, when summed, equals 10, and return their indices plus 1. Right, added by 1. So we know that 2 plus 8 is equal to 10, and normally in an array this would be an index of 0 and 2. But basically in our problem we're told to start with an index of 1, so I have numbered them accordingly, starting from 1. And what we would return in this case is an array with the two indices, which will be 1 and 3. Right, so that will be what we want to return in this case. So the brute force solution for this problem is basically the same one as two-sum 1, right? Where we want to look at every combination of these numbers and see which combination is equal to 10. And in order to do this, what we want to do is we want to find every combination possible is we will create two for loops, an outer for loop and an inner for loop. So with the outer for loop, we will start off with one of the numbers. So we're going to start with 2 first, right? And then what we want to do is compare 2 along with every other number in the array, right? So we are going to see if 2 plus 7 is equal to 10, and it's not, 2 plus 8, and so on. So we do it with every number in the array, right? And after this, we would move our pointer in the outer for loop and go again through the inner for loop to compare with every other number in the array, right? So basically, in order to do this, we have a double for loop, and it will be an O of n squared time complexity in order to achieve this, right? So I'm just going to write the code quickly here, right? And basically, if we have an input of numbers and target, what we would have is for I in range of 0 to length of numbers in increments of 1, for j in range 0 length, well, not 0, we would start from I plus 1, length of numbers and increment by 1. we would say if um, target minus nums of I is equal to nums of j, then we would just return I plus 1 and j plus 1. Right? So this would be our code, and we would see that because of these two for loops, right, we have an outer for loop and an inner for loop. And because of this, it will be an O of n squared time complexity. Now, the reason why in the inner for loop we are comparing from I plus 1 is because, for example, when we use the number 7 in our outer for loop, we have already done the comparison along with the number 2 in the previous for loop. So there's no need to repeat that comparison. We could just go on with the for loop starting from after the current number we are looking at. We don't have to look at the numbers preceding it. However, we want to try to improve this time complexity, make it a linear time solution, right? So one thing we could do is take advantage of the fact that the numbers are sorted in ascending order, right? Because they're sorted in ascending order, we know that the last number is the largest and the first number is the smallest. And this can be very useful for us. So I am just going to take this. I'm going to copy it and let's put it back down here. So yeah, so we still have the same problem, but how can we take advantage of this ascended array? Well, what we could do is we can use 2 pointers. So we'll have one pointer starting at the beginning of the array, which is our left pointer, and another pointer starting at the end of array, which is our right pointer, right? And so the left pointer is pointing to the smallest element in our array, and the right pointer is pointing to the largest element in our array, right? So in this case, what we're going to do is we're going to see if these two numbers is equal to the target. And we see that we have, in this case, a 2 and a 13. So we check 2 plus 13, and we see that it's equal to 15, and that is greater than target, right? It's greater than 10. So what we need is we need a smaller sum. Since we have these numbers sorted in ascending order, we know that that means we would have to move our right pointer to the left, towards the left, to a smaller number, right? So what we're doing is we're basically shifting this to the left by 1, and we move our right pointer here. Right, now again, we do the check, and we see that 2 plus 11 is equal to 13, and that's still greater than 10. So again, we are going to move our pointer here, 1 to the left, and we have our right pointer at index 3 now. Right, so again, what we're going to do is we're going to check our 2 plus 8 in this case. Right, so now we have 2 plus 8 is equal to 10, which is equal to our target, right? So we have found the indices of the two numbers which equal to the target, and we can return the indices. Now, one thing to note, however, is that in this case, what would happen is if we have a case where, for example, we're doing 2 plus 7, which is smaller than our target, 10, then what we do is we would shift our left pointer to the right and continue our algorithm. However, this does not occur in this given example, so it's not necessary for our example. But if it is smaller, then we would move our left pointer to the right. So we can go back to LeetCode and write up our solution. The solution will be a linear time complexity solution because we only have 2 pointers and they're traversing the array only once. So it's going to be an O of n time complexity. Okay, so we're ready to write up our solution. We're here back in LeetCode. And as we said, this more optimal solution, which is an O of n time complexity, we want to take advantage of the fact that the numbers are already sorted in ascending order and use 2 pointers. So we're going to declare 2 pointers. They're going to be left and right. Actually write out left and right instead of L and R. so it's more clear for you guys. And we're going to start these left pointers at the indices of 0 and length of numbers -1. Right, so we're going to start these at the beginning of the array for the left pointer and at the end of the array for the right pointer. And we're going to say while the left pointer is smaller than or equal to the right pointer, so while these pointers do not cross each other, we're going to have some if statements to check if the sum is smaller, equal, or greater than our target. So we're going to have our sum equal to numbers of I plus numbers of j, right? And what we're going to see is, in the first case, if the sum is smaller than our target, right? And in that case, what we wanted to do is we said that we wanted to move our left pointer to the right. So we're going to increment it by 1. And this is not I and j, this is left and right. So we're going to increment our left pointer to the right because we need a greater sum. Then we have else if the sum is greater than the target, then what we want to do in this case is we want to make our sum smaller. And in order to do this, what we need to do, since it's in ascending order, this array, is decrement our right pointer by 1. Right, and then our last case instead will be is if the sum is equal to the target, and in such a case, what we're going to do is just return the indices incremented by 1 as requested in the prop. Right, we are told that we will have exactly one solution, but if we wanted to take care of that outside of the for loop, if we never find a solution, we could just return -1 and -1. However, this will never occur. We are guaranteed one solution. So this statement will always execute for any given input. And yeah, so we can see if this runs. Hopefully I didn't make any typos. So it runs. And let's see if it submits. Yep, so it submits. I'm just going to submit it again. And we see that it's pretty efficient. Sometimes the runtimes in LeetCode are not very accurate. Resubmitting the same code will give you a very different result. But this is the most optimal solution possible. It's a linear time complexity solution. And thank you guys for watching this video. I hope you found it very useful to understand this.